Hey guys, welcome back to Helper Function. In this video we will discuss a question, valid anagram. So the problem statement says that given two strings s and t, write a function to determine if t is an anagram of s. Now what is an anagram? Two strings are said to be anagram when one can be formed by rearranging the letters of other. Now these four strings are anagram of each other. If we swap C and A of first string, we will get the second string. If we move the first character of the second string to the last, we will get the third string. And if we move the first character of the third string to the last, we will get the fourth string. Thus, these strings are formed by rearranging the letters, and hence they are called anagrams. So for this example, string s and t are anagrams, and thus we will return true. But for this example, s can never be obtained from t, as s contains character e, but t does not. Thus, the basic requirement for two strings to be anagram is to have same characters. And also, the frequency of that characters should be same. So let's see how we will solve this. Now one approach to solve this problem is to sort both the strings and then compare them. If they are equal, then they are anagrams and we will return true, otherwise we return false. Now this approach works because if the strings have same characters, then if we sort the both strings, they should be same. But the time complexity of this approach is order of n log n because we are sorting the strings and it requires n log n time. We have another approach which can solve this problem in linear time complexity. As for two strings to be anagram, the count of each character should be the same. So we will count the frequency of each characters of both strings and then compare all the characters. If their frequencies are same, we will return true, otherwise we will return false. So in this example, for string s, the count of character a, c and t is 1, and for all the rest of the characters, the count is 0. Similarly, for string t, the count of characters a, c and t is 1, and all the rest of other characters 0. So if we compare the frequency of characters in these two strings from a to z, we will see that they are same and thus we will return true. But for this example, the count of character t in string s is 1 while in string t is 0. Also, the count of character p in string s is 0 while in string t is 1. Thus the frequencies of each character will not match here and we will return false. Now let's see how to do this efficiently. Now one basic thing is that if the size of both the strings alter, we will return false immediately as they can never be an anagram. Otherwise, we take an array of size 26 that will represent characters a to z. 0 will represent character a and 25 will represent z. As in ASCII form, a to z is represented by 97 to 122, so we will subtract 97 from each character to get their index between 0 to 26. Now for every character in S, we will increment its count by 1, and for every character in T, we will decrement its count by 1. So if they have same count of each character, then my array should have value 0. And now we will go through all the 26 characters. If their count is not equals to 0, we will return false, otherwise we return true. Now let's quickly look at the code. We are given with two strings s and t. Now if the size of both the strings does not match, we will return false. Otherwise, we declare an array of size 26 initialized with 0. Now in the for loop, we are incrementing the count of every character in s by 1 and decrementing the count of every character in t by 1. Let's say my current character is b, so this si will read 98 and thus 98 minus 97 will be 1. Thus a to z will be represented by 0 to 25. Note that the strings only contain lowercase characters, so we are comparing only these 26 characters. And now in this for loop, we will go through all these 26 characters, and if their count is not equals to 0, which means that the frequency of this character in both strings is not same, and we will return false. Otherwise, this loop will terminate and we will return true. So let's try and run with this example. Here the size of both strings are same, so the if condition will not work. And we will enter the loop. So at first, for character C, array of 2 will be incremented by 1. And for character A, array of 0 will be decremented by 1. Now for the second index, array of 0 this time will be incremented by 1. And as it is -1, it will become 0. Similarly, for character C in string T, array of 2 will be decremented by 1. And as it is 1, it will become 0. And now for the last index, as both characters are same, they will increment by 1 and decrement by 1, resulting to 0. Thus now, if we go from 0 to 25, we will see that array of I is 0 for every character. Thus, we will return true for this example. Thus, this problem can be solved in linear time complexity. Note that we are using an array of size 26 here, but this can be considered as constant size. As for a string of the size 10 to the power 5 also, we will require this much space only. So this was all about the problem. I put the problem link in the description so you can go and solve it. If you like this video, do share and subscribe to the channel. See you in the next video.